switch the presentation to the screen. Okay. So tonight we're going to talk about risk. And as you can see the lovely mating out there, they don't see any risk in what they're doing, but I certainly would. So, what am I going to talk about? I am going to talk about risk-based testing, what it is, how I approach it, what sort of tools, techniques, how do you go about doing it, what results can you expect, and so on. So, traditionally speaking, risk-based testing is a kind of means of prioritizing testing. It's a way to sort of say, okay, I can see risk, and as a result of that risk, I'm going to do things that de-risk something first. Often we think about risk in a project sense. We say things like timeline are at risk, or resources are at risk, those kinds of things. But when we talk about testing, we should be talking about the risk of something going wrong with whatever it is we're testing. It's software, which most of us it is. It's going to be something around something going wrong with the software that stops some functionality working, prevents someone from being able to get value from the software. This traditional view is you want to reduce risk to an acceptable level. Hopefully everybody here understands that exhaustive testing, complete testing, you can't do it. It's not possible. Like, we don't have infinite resource, infinite time to do that, right? So we have to pick and choose what we can do. So another thought about the prioritization is make sure you're spending time on the highest priority risks first. It's no good looking at things that kind of, I don't know, you know how to do, so you focus on those rather than the thing that you actually think might go wrong. It's no good looking over here when the focus are likely to be over there. Something we use the kind of risk model to sort of say, how much time should I spend on things? How should I plan my regression testing? How should I plan my sort of Scrum cycle, etc., etc. And a lot of folks in the traditional sense use it to facilitate test design, like how do I choose which are the right things to test, or which are the right inputs, or configurations, or requirements, or any of those things. It doesn't mean for me. Some of those things are appropriate, some of them aren't really appropriate. For me, it's really about efficiency. It is about spending your time efficiently. Already sort of made the comment that we all know that exhaustive testing is not possible. You can't do it. You can think about simple things you can just have calculated. Permutations involved in actually thoroughly testing the calculator, algorithm if you like, are almost boundless. So make sure you're spending your time doing the right thing. Spend your time on the highest risk. If you spend your time in a risk-based way from high to low risk, and someone says to you, we're out of time, or you know you're out of time, you can have the confidence to say, I've hit the highest risk areas first. I've done the most important stuff first. It's a good way of kind of answering the question of when are you done? When will you be done? Because we all get that question. Folks who heard me speak before know that I'm someone who focuses on defect prevention rather than detection. I hate the idea of kind of like waiting till the very end, so everyone's done all their work, and then we're there trying to catch the bugs before we ship the software. It's a crazy situation and totally inefficient. So the biggest thing I do with risk-based testing is use it to prevent rather than detect. So you're trying to analyze the risk and actually prevent it from happening in the first place by stopping someone from coding the thing that's actually going to result in that risk becoming reality. As I mentioned earlier, you can use that kind of risk-based thing for there's conversations around, am I done? Have I done enough? Have I done the right things? You can provide that kind of focus and clarity around like a release decision or a go-no-go type situation to say, I covered these high-risk areas, I didn't cover these medium or these low-risk areas, so the business can make an appropriate decision about whether you should ship something. And of course, you can use it in the reverse sense as well. When something goes wrong, you can look back at what you did and say, did I analyze the risk correctly if I missed this thing? And you can readjust and learn. A wall of text, a few walls of text, but I'll post the slides later. So, how do I approach it? Again, I've talked about this a few times before, but start at the beginning. If you're not involved at the beginning of the conversation about whatever that piece of work is you're doing, you can't really help prevent some of the things that are going to go wrong with that. You can't help prevent about some of those design issues where someone says, okay, customer wants this feature, and dev just goes, oh, I know how I'm going to do that. I'm just going to make a change over here and do this thing over here, and then we'll be good, right? And then you eventually hand that to the person. If you're not involved in that conversation, you're very unlikely to figure out, is that design a good design? Is that design going to lead to some level of risk that I could avoid, mitigate? I kind of want to say that begin with asking questions about the change. Focus on change. Any area of change is likely to be the highest area of risk for whatever thing you're working on. So if you're working on a software product and someone wants a new feature, the chances are the feature is going to change certain areas of the software, but it's not going to change them all. So if you understand where the areas are changing and how they might be used in the product, you can actually understand the risk of it. What I mean by develop your understanding is you're deepening your understanding of how the software is architected, how it's put together, what sort of things you need to understand about it in order to relate it to how the customer uses it, all those kinds of things. Developing and growing your understanding. The quickest way of doing any of these things, and the quickest way for me, at least for understanding risk, I'm a very visual person, draw diagrams. Simple models of how the system works, simple models of the architecture, data flow diagrams. Use UML if that's something you're familiar with. Use sequence diagrams to talk about what happens in what order. I challenge a lot of my careers to do this, but even if you're not good at drawing diagrams or don't know what it is you're about to draw, just try drawing something. If you've got a dev in the room, the chances are the dev's going to go, no, that's not right. Now get up, now start drawing. And you've achieved what you wanted because you then get the diagram you needed. Once you've got a diagram, you can start pointing at it and saying, no, that didn't work. And what happens if this doesn't work the right way or get the right response or whatever? Big fan of heuristics. So if you use heuristics in this kind of risk analysis way, then you're using them to form the questions that you want to ask to get the understanding you need to understand this. So you're using a heuristic to sort of prompt you or prompt the person who's speaking to you to say, what if, or what about, or have we thought about this, or does this apply? Once you've done all that, of course, you're then identifying these areas of risk. If you've got a diagram, you're kind of pointing at the diagram and saying, okay, this is the highest risk area, this bit right here, this bit of code that you're going to change. And once you've done that, then you can talk about the kind of, some people call it the risk probability index, the RPI, but it's basically how likely is this thing to happen, this risk to become reality? Like, have I got any guess or any data to tell me this is really likely to turn into something that's going to cause a problem? And then what's its impact if it does? Because you can have all sorts of situations, and I'll cover it again later, but it's that idea that something can be highly likely to happen, but if it happens, the impact of it happening to a customer or to the user of your product, they don't really care. Stupid example being a typo, right? What's the likelihood of someone putting a typo in a UI page? Well, it's probably reasonably high, but I think the impact of it's probably not that high. But if you've got a complex piece of code and someone's about to make a change in it, and you've got one of those developers who's telling you, I hate touching this bit of code because it's really flaky, and they're about to change it, then the risk likelihood of something going wrong with that is pretty high. And if that's a complex area of code, it's probably quite critical to your product, and therefore the impact of it could be quite severe. So when you've got a combination of those things, you have a high risk. So you assess that against the things you've already kind of identified as big risk, and you're now assessing the likelihood of them happening and the impact of the impact. Once you've done that, you've got this kind of this idea of how do I prioritize. Because now I've identified these areas that are highly likely and high risk. Those are the ones I'm going to focus on first. So now you kind of have your means to prioritize. And obviously, anything you can't avoid, so any of those things you can't completely sort of say that let's not do it that way because that will give us this risk. If you can't, choose a different way, you have to live with that risk. You have to make that change to that complex piece of code. And think about mitigations. Mitigations are often, for us at least, that the test you're going to write to say, I'm going to make sure it still works when you've made that change by doing these tests. Those tests should be focused on mitigating that risk. I'll go really with it. It's a lot, and I've just talked about like a large part of your software development lifecycle in one slide. So, what do I really mean? So, most of us, hopefully, are involved in the requirements phase. Whether it's a real phase for you, or you're using Agile or Scrum, in which case it might be like a thing that happens during your sprint cycle or your software development cycle that takes a week or 2 weeks or a month to do. If you are able to get in front of that and talk to the person giving you the requirements and to the developers who are going to answer those requirements and try and solve that problem, you can ask that first question of what is it we need, what is it we're doing, why are we doing it? So you want to understand what is the benefit to someone, why do they care? Because as soon as you understand why they care and what the benefit is to them, you've got a better idea of what's the risk if this doesn't work, what does it mean to them if this doesn't work, like how much impact will it have on them if this doesn't work. So you're trying to get a description of that sort of, or an understanding of that sort of benefit proposition of doing this feature. Is it going to enable new sales? In other words, if this thing totally fails, are the old sales still good, but we can't get new ones? You get it? Sometimes you get those kind of requirements or those kind of feature requests that might actually be solving something internally for you. You might have one team requesting something of another team that, hey, you guys, I need you to build an API so that I can query that API and get data from it. Because I need that for my part of the product. In which case that might be something he's solving something for us. So it's an internal kind of requirement or internal kind of like benefit statement that we get. How we solve the problem is kind of what I meant by how is a developer or how is a team of developers or multiple teams of developers getting together to figure out changing our code from where it is today to solve this problem, where it's going to be tomorrow. How are we changing our architecture? How are we changing our database? How are we changing our services, our APIs, or any other interfaces? Again, get someone to draw a diagram. If someone isn't going to draw a diagram, just start drawing something. Try to get someone to help you with that, help you understand it. Just at the beginning, I'll take questions anytime. I'm saying something you don't get. So, we give you a diagram. For anyone who's actually interviewing with me, this is actually one of the diagrams I use in the interview. There's some text below that explains it, but I'll give you a quick sort of walkthrough. So, essentially, this is kind of a simple model of part of our system. It doesn't really look like this, but this is a simplified version. So, on the client side, you have a client browser web UI, which is essentially we're a market research software company. This is essentially like answering a survey is what I'm talking about right here. So that client browser web UI is like a web form where you enter some data or click on some yes/no type questions and then submit the answer. And the answers are coming through to the server side, and one of the first things we do is we put those answers on the queue, and then the app code there, the box in the app, is basically taking messages from the queue, it's parsing those messages, taking the information from them, and storing them in DB. And then we have this periodic piece of code, data sync, which is every period, let's just say it's a day, is calling the app code and saying, okay, what new data do you have since the last time I called you, which was yesterday? Give me that data and I'm going to go push it off and store it back. And that just means it's an eventual consistency type back. And this is what we use in our interview and kind of ask people like to analyze the risk in this diagram. So, how do you do that? I could make this interactive and actually make you do that, but it's easier if I start talking first. So, big wall of text, right? Yeah, I don't expect you to really read that. What I'm really trying to get across is there's an awful lot of things you should think about. So this is just one list, and I call these the quality criteria categories. You can think of this as kind of like some of the kind of high-level, outside-in focused categories. So I can just go through the list quite quickly. I'm talking about data flow, I'm talking about reliability, usability, performance, compatibility, supportability, testability, maintainability, spot the pattern with the ellipses there. Upgrade, delivery, portability, localizability, accessibility, monitoring. Now, guarantee you, not all of those are going to be applicable to whatever it is you're talking about. But if you have a list in front of you, it makes you think about these things and makes you think, is that applicable to what this thing is? Do I need to care about some of those aspects of this? Some of them are a little kind of more esoteric in the sense of like, the things about monitoring. Then you need to think about monitoring. If you're not in ops or DevOps, then you're probably not thinking about monitoring. But something for another talk is tests as monitors and monitors as tests. Like you can actually think of some of the things you tests as being something that the operations code can use as monitoring the system to see if it's working well in production, vice versa. So that's one list of things you can use to say, I might have just seen a diagram and just have a blank mind, and not know where to start, what questions to ask, anything else. Is it start? So get you going. It's not the end. So there's the generic list. This is another list that I use and kind of help prompts and thoughts with. And this is things like popular, complex, new, changed, upstream dependency, downstream dependency, critical, resource utilization, precise, strategic, third-party, distributed, buggy, or recent failure. Now, a lot of these things, you're probably doing them naturally, you just don't know you're actually doing it. So, let's just take an example, popular. Like any part of your system or any kind of UI page or anything like that, that's used a lot. It's a frequently visited thing or frequently used thing or a code path you can frequently go down because it's kind of a critical part of the system. Buggy. We all know this one, right? Like, I'm gonna spend time on that bit of the code because it always goes wrong. We all use our bug history as a kind of like mental heuristic sort of approach to the system. Something sadly people don't often think about is resource utilization. What is this thing consuming, and how is it consuming it, and in particular, how is it freeing it up? If you have things that like consume database connections, is it consuming too many, and how many can it consume? Can it actually starve the database of connections, and therefore stop anything else in your system actually having access to the database? It's a big list. A lot of things to think about. You come up with your own. So you know your product, you know your domain, so you know the kind of space that your company or your product is working in, and you know your team, your systems, your test history, and all those things. Come up with your own list. What do you see often? Come up with your own list of things that you need to remind yourself to think about. If you're anything like me, you actually can't remember more than about 4 or 5 things at any point in time, so you need a list to help you think about some of these things, to help your team think about some of these things. We mentioned a couple of these earlier, right? So are there areas of the code that are fragile, are there areas of the code that developers don't like working on? We have all of those. And are there things that we often forget about from an NFR point of view, like, actually, is it important that this works in French as well as English? Is it important that maybe it performs a certain way under certain conditions? We often forget about those. So come up with your own to come up and use that as an idea to have some of those conversations. Use a heuristic. So most of that previous sort of set of lists was kind of gleaned from my experience and from other people sort of putting their own kind of lists up there on the web. A lot of it comes from James Back and Michael Bob. One of the websites that you can access some of this from them. And James originally came up with this one, which is deeper. And the original one is the one without the I or the E. Recently got one, recently, but years ago they added the I or the E, and it's kind of like choose your intervention, or you can make this fit whatever you like. But it's a useful way to think about this. If you think about the previous diagram, you think about structure. The diagram is giving you some semblance of structure. But you can think about more about that structure, like how is the database structured? How are the web services structured? How is the queue structured? What does it mean when I say structure? And you can think about the function. The function of things is typically what we all think about. Think about the data. Where's it going? Where's it coming from? What does it look like? What shape is it? What size is it? All those things. Just use these heuristics to kind of get your thoughts flowing around. So, already mentioned that we often don't think about performance, but it's kind of a critical aspect of that. So that link up there is actually a link to the kind of full definitions of each of these. It's another one by the same folks. It was originally pickups, and then they kind of added a few bits. You can see it's a similar sort of idea of just using kind of a simple phrase or whatever it is part of a heuristic. The heuristic makes it easy. Mnemonic, sorry, makes it easy to remember what it is. The heuristic is just a list of things to prompt you, to make you think about certain things. So this is very much a system level kind of black boxy type of thing. Right? So the previous one is slightly more, I find it slightly more useful against something where you have a diagram, you have some understanding of the architecture. This one's more useful when you're dealing with a complete black box, like you've got a product that you don't understand the internals of at all. Because this is where you're talking to things about that product that kind of are knowable outside of it. We know, things about how familiar you are with the product, how familiar customers are with the product, and you can test yourself on how well you can explain the product to someone else, or how your sales folks will explain it to someone else. You can talk about the world in which the product lives, the environment, or any of those kind of things. History could be anything from the history of the product as how it was developed, it could be how it was used, or it could be, as we talked about, the bug history. It could be what problems have I seen with this one. Things like claims is really saying, like, what do I claim about this product? Do I claim that it works with 1,000 users, or do I claim that it gives you a response within 1 second? What claims am I making in that? There's a few more. I've invented a couple. On our website, I can actually show you them if you're interested. There's one for a UI page, which I find quite useful. Again, because I can't remember everything, so I use a heuristic to do that. Another one for Star Wars fan, since it's kind of Star Wars, skips a bit earlier. With the keystone correction problem. There's one for AGAs. We do a lot of AGA work here, REST AGAs. So one that helped how QAs do that. So that's all of the kind of ideas around how you have some of those conversations to analyze the risk. That's all those kind of thoughts about the questions you want to ask, or the things you need to understand, or the things you need to kind of be clear about. Do I need to test? Do I need to make sure something meets some criteria? So once you've done all that, as I said, you're then going to try and assess, based on what you now understand of the risk areas, what's the likelihood of it happening, and what's the impact of it this time. So along the top, the x-axis, if you like, is the impact. So anything from negligible, in which case, like we don't really care, to some minor kind of thing, and maybe it's a bit worse than that. So it's kind of a moderate impact, significant impact. Someone can't do something they really want to do, but they can still do other things. And it's severe. It's like, okay, I can't do critically what the product is meant to provide for me in terms of value. I can't do that thing. And then the kind of y-axis, if you like, is the likelihood. Right? So it's like very unlikely. It's not going to happen. Not going to see that risk. It's not going to turn up in reality because it really needs a particular customer, like a snowflake customer doing this really weird thing, this really dark corner of the product that we don't often use, and it's used once a year. All the way up to this is an everyday part of the product, and someone's going to hit this all the time, or all of our customers are going to hit this because it's in that critical path. Make sense? Let's make it a bit intro. How would you apply some of those things to this? And want to throw out some ideas. It's not going to work, is it? So remember that if you come interview with me. What you would really do is start asking questions about it. Right? One of the things that there's a bit of a trick in this, very few people actually spot it, is how many of you have dealt with this kind of situation where you've got a web UI and it's kind of posting data back to a server? Any of you? Do you know how the system works like that? Okay. Something missing here. I can't just have a web form post going to a server and it hit a queue. Something has to process that thing and put it on a queue. So there's a box missing in my simple model. And it's one of those classic things of like when you do this in front of a developer and you sort of say, well, I'm going to try and model the system as I understand it, and you can tell me what's wrong with that, but I want to model it so that I can talk about the risks. I hope the developer's going to say, well, that ain't going to work, is it? That's not right, or it's not the system we've got, or it's not the system we want to have if you're talking about something that's brand new. It's missing a bit. But when you've got a diagram of this, you can start pointing to things and saying, okay, so I've got flat web browser and millions and arrows saying that something goes from there to the queue. So what is that? What is that data? What does it look like? What form is it in? And has the UI done any validation on that? Is there anything telling me that data is safe to come across this? You can see what I mean? Like you can start using those lists when it talks about data flow, or it talks about maybe security. Think about the security aspects, or about the performance of how many client web browsers might I have? How many do I need to handle? Apply some of those things to size of it, the size of the data. How often am I going to get that data? How often do I need to process that data? So there's a ton of things on those lists. You could apply all of those lists. You could go nuts on this for weeks. Yeah.
When you mentioned the box there in front of the queue, do you see that box as including holding up all the messages that are in the queue, or would that be separate?
No, what I mean is something's going to receive that web form post. Something's going to basically take that post.
Or it's putting it onto a message queue.
Yeah.
Where's that message queue there? Is it part of that same box, that same process?
Potentially. So here's another good question. Are you assuming that all these things on the server side means that's one box? Because I can tell you for us, it's not. But it's again another thing you want to ask to clarify. Right? Am I talking about one system or not? I mean, wherever you put a line, you could assume that line means that there's some sort of like call or connection, something else. That could easily be a network connection. It could be a call from one system, one box to another box. It could be a call from one virtual system to another virtual system. So these are all things that you need to do. Like if you get that diagram in front of you, if you draw it, someone else draws it, you can start asking questions that really deepen your understanding of this thing. As soon as you know there's a connection that's going across a network, then you've got network risk. What happens if the network isn't there? Or I can't talk to that thing, whether it's a DB, another system, a service, whatever. All of a sudden there's a risk you can mitigate in terms of infrastructure, in terms of monitoring. Bring that all back again. So the idea is you're just going to poke at this with all the things that you can think of poking at it with to try to understand what it really means and where the risks might be. You're trying to do that to come up with what am I most concerned about? Where do I think that the biggest risks are? And if we assume in this diagram that for the new feature that we're producing, we're actually touching each one of these boxes, then we've got effectively risk across the entire thing. We've got to find out now what levels of risk do I have. So if I kind of do that roughly, I have done this roughly, I'm kind of saying that the red indicates like a high risk and the kind of slightly orangey color isn't projecting very well. These are kind of medium risk and then the low risk is and I'm arbitrarily doing that just to share with you some idea of how you might do this on a whiteboard or anything else. Right? And so the problem I've got now is I've got 3 areas of high risk and 2 areas of medium risk. So now I've got to do some more work to say like which one's the riskier of those things. And I'm going to ask questions about what's changing. How much is changing in the client browser and how risky is that change? And how would I categorize or understand that change in the sense of what that risk, in the sense of how likely it's to happen and the impact of it. If you can't use that web UI, then you don't have much of a problem, because if that's the only interface your customers have to work with you, which in our case, it's that kind of getting that survey feedback to us, that is the way they get it to us. If that doesn't work, or doesn't render for them, or doesn't render correctly, in a way that they can provide us with that information, then we've lost our value entirely. So critical for business is that piece. But if the change we're making isn't likely to impact that, so it isn't likely to break it, maybe it makes it not branded. So maybe it doesn't look like Starbucks. When the Starbucks customer gets that thing, maybe it looks like, oh, it's got vision critical on this, that's weird. Oh, it's a Starbucks. They can still answer the survey, but it's not branded. So that's still a critical thing. Get the idea? Put in that extra box that was missing to get that now. And on my queue, like, this is a classic for us in terms of bug history, we have a lot of problems with that. It's a complexity in our system that was kind of designed in with good reason. It's actually a performance mitigation thing that we're doing. It's a buffer, effectively. But it gives us no end of trouble. So I know, because it's our domain, it's something we're familiar with, that this is a problem area. Now, obviously, if you didn't know that, if you didn't kind of work here and have that experience, then you might not associate high risk with that. And that's okay, because that's one of those things that you can only do this based on the knowledge you have, or the questioning, or the answers you get back. But I mark it high risk because I know how high risk it is, and obviously, it's kind of a crucial part of the chain. If that queue breaks, or if we lose any of those messages, we've effectively lost some customer data. We can't do that. That's our business. So if we have problems there, it's serious for us. I'm going to go the other end now and talk about the low risk thing, just to give an example. So among the database could be a bunch of reasons, right? It could be we're not making much of a change in the database. Maybe you know, I'm adding a column, or I'm adding a column constraint, and that's not a big deal, right? And it's fairly easy to sort of mitigate in terms of testing and you know, from a SQL point of view, like getting a DBA to review your SQL code change and making sure that's the same change. But it's to be easy to check in a local kind of way. Like I can do that on my local version of the DB and play around with that quickly and tell whether it's broken. If I'm coming up with a new DB schema as a result of this new feature, then I'm going to want to do some serious work with that because the change is high level, the risk is high with that. Code. It's a lovely small box and it's not really any bigger than anything else there. But actually, this is the entire business logic of the response production system. So for us, again, I have that internal domain knowledge. I know this is the most complex part of our code. It's not true now, but like a long time ago when I first joined the company, this was an area of code where senior developers are like, I don't want to touch that. I'm not going near it. There's no unit test, there's no decent sort of integration test, nothing. I'm not going near it. So whenever we had to do features or changes in that area, it was like, don't want to do it. And if you do it, we're going to test the hell out of it because it's probably going to break. So again, it's another one of those things where you can associate risk with that sort of like popular, critical, complex. It's got all of those things going for it. Even if you wanted to, you can take those lists and use them as scorecards and say if it ticks more than one of these boxes, then it goes into a category of risk. It's a quick way of doing it. So, orange stuff is stuff like they were making a change to the API of the front end service, but it's medium risk because we do that quite a lot. We're quite well versed in sort of making new API endpoints or kind of changing some of the parameters around the API, so it's not that big, but because of where it sits in our system, it's that receiving point for that data. There's still an amount of risk to that. It's kind of so I'm doing this very arbitrarily and hand-waving you, but I'm trying to give you an idea of how this might look, what sort of artifacts you might produce as the process of going through this kind of risk analysis. I've got a duplicate slide here, but what you're going to do once you've done that sort of thing is you're going to then dig deeper into each of those risk areas. And I've kind of just done that for you. So it's if you say, let's just pick one. Say it's the client browser web UI, which you're probably most familiar with that. Right? If we pick that and say, okay, that's the highest area risk, that's the highest probability of something going wrong, and the biggest impact if it does go wrong, as I explained, no one can respond if it's not working. Pick that, you're going to dig deeper into that. What that really means is I'm choosing to spend more of my time talking about, thinking about, analyzing, and challenging and questioning and coming up with test cases around that. So if I've got a week to test this thing, or a week to think about testing this thing before I get the code and then I have to test it, I'm going to spend the bulk of my time thinking about that and understanding that, keeping that. So even if that, is a short space of time for you, arguably it's even more important if it is a short space of time for you to focus your time. So I'm going to make that, like 60% of my time spent on this project, whatever that 60% of time is, I'm going to focus on thinking about that. This is all before we got to the point of actually getting code or getting test cases right. We're just thinking about what could go wrong and how am I going to deal with that? How are we going to deal with that? Sometimes we're trying to avoid the issue by saying to them, don't change it that way because that always breaks us when we change it that way. If you change CSS, make it really careful and well code reviewed and tested on your own box type of CSS change with multiple browsers. Make sense? So I've gone through this super quickly. So I realised I missed a few slides as well. So I'll talk about the definition of risk-based testing, like both the traditional one and kind of my version of that, which is a simpler, shorter, just do it for efficiency, just do it for prevention. And I'll talk about a few tools. I think of them as tools because they're not commercial things you buy off the shelf, but they're tools. They're things in your tool belt, they're things you can bring to that discussion, to that whiteboard, that whatever meeting you have to help you analyze the risk, to help you determine the risk and determine how you should focus your time. So there's questioning, there's diagrams, there's heuristics, there's risk making. All of those. I gave you some quick examples and talked to some of those. You come out of this with maybe it's a photograph of a whiteboard.
It's a great cheap thing to do. Have a lovely diagram and maybe some scribbles all over it saying high risk, or maybe colour like I've used to say like, you know, this is red, so this is super high risk, or this is yellow, this is low risk. And you're going to have that as one of your artifacts. And you're going to have the ability or the really crude estimate of how you're going to spend your time. You know, maybe you're just going to swag out saying, okay, it's meant to take me a week to develop and test this thing, so I'm going to spend 3 days working on this bit, and then I'm going to spend 1 day on this, half a day on that, and then split the other half a day between the other two areas if I get that far, because then the low risk that I may not get. Hopefully, you've done a lot of defect prevention. With any luck, you've done that before it got really expensive. In other words, you kind of prevented that defect right at the beginning when someone was about to make bad design choices. I kind of quoted this to someone the other day, that one of the first teams I worked with here that I was doing this kind of risk analysis with, hopefully it's once game, we spent about 7 different sessions going over risk. And let's just say those sessions were an hour long. So that's 7 hours we spent talking about and completely new feature that we were going to build on top of the existing. It was actually in responding. Okay. Now, one of the senior developers, it was a painful experience, right? Because we're locking everyone in a room, we're whiteboarding and going through lots of different sort of conversations about, like, well, how about we solve the problem this way? And poking holes in that solution and kind of, you know, iterating over it is the gentle way of saying it, but like scratching that whiteboard and kind of coming up with another one and going through this process. The senior dev at the very end of it said, that was really hard work, but we went through 3 different designs. We had 3 different solutions that we effectively evaluated and threw out or tweaked, come up with one at the end. And he was willing to say that if we'd gone ahead with that first design, we would have been rewriting it in a few months. And it was 7 hours. It was expensive, it was hard, like 7 hours in a room, and it was not one day. We actually ended up doing this over a few days, and that was my time, so it was really hard to find. That 7 hours was much better than having to rewrite it down and take 3 months down the road, which probably would have taken another couple of weeks. Introduced another bunch of bugs. So hopefully you can sort of get some of that value. I can really tell in the room at the moment you have that value, like with the, excuse the expression, with the oh shit moment. Like, okay, you're not hearing me. Better?
I think it does.
Sorry?
I think our mic does.
Really? I actually think you're right. Okay, I'll just show. I call it the oh shit moment because you're talking to the dev and you've got the diagram up, they've drawn the diagram, whatever. You're pointing to something and you say, what happens if that doesn't get the data you expect? And they kind of just go, think of that. And then you've got that kind of like immediate value add that you've given them in the sense of like they would have coded it a certain way, they wouldn't have dealt with that issue, and now they're going to code it the way it is to deal with that issue. I didn't talk about this, and I should have done, verbally talk about it, which is you're going to come out of this with some test cases. And sometimes those test cases are going to be like system level type stuff where you need to take care of something when it's all put together and you've got everything and you can say, right, I'm going to run this test to make sure that end to end this whole thing works. That it works in a certain way with certain parameters and certain configurations and environments. Some of that, with any luck, is much lower level because you've got the dev in the room. You're going to be talking to them and you're going to be saying, okay, there's this area of code that's really complex, like the app code. And we've identified that the change you're about to make is going to make a change in that app code that makes, I don't know, a different decision than you used to make. And that decision is based on something you're getting from the DB, something that's part of that message, and maybe something about the environment or the config or the customer or whatever. And you can say to them, so when you're going to make that change, I'd like you to test these things. I'd like you to isolate that piece of code that's making that decision. I'd like it to have these kind of input values, you know, fake getting that thing from the DB, fake getting that thing from your environment, and then make sure that the decision it makes is the appropriate decision, and it should be this. In other words, you're using your kind of testing and kind of almost black box testing skills to help the developer understand how you want to see them write an automated test at the unit level or integration level that's going to mitigate the risk that you're potentially seeing. It's something that could go wrong with that complex bit of code because it's the area where you're changing it and it's a particular permutation of data or input test case, test result type mapping back to the risk to talk about that no-go decision, that release criteria situation where, okay, here's the testing I did in the sense of here's the risks I understood and I identified at the very beginning, or we preferably, if you can do this with the other folks in the room, and then say, and here's the test I did to mitigate this risk, and you can see these test patterns, and I focus these tests on all of the high priority areas, and again talk about that idea that I worked through them from high to low, and maybe I didn't get to the lows, but here's what I did cover and what that means. Then you can have a much stronger and much more confident conversation about should this go to customers or not? Should this be shipped or not?
What if you don't do this?
What's the opposite? If you don't approach testing this way, what happens? Assuming some of you have experienced some of the bad stuff, I definitely have. If you don't do it, you have to say okay, that's like. What I mean by that is you're not going to prevent anything, and you're going to wait until the very end and everything's done and you can test it and then figure out whether it actually works. And that can be a week, sometimes it can be a month. The worst projects I've worked on, it's almost 18 months after you started the project, so when you actually get to test it and figure out whether any of the things that you might have thought of at the beginning actually were the risks become reality. I mentioned this at the beginning as well. The risk is that you only test what you know. So, let's say, for example, you're very familiar with testing UI. And you've got a lot of experience of working in different companies, testing web-based products where you test the UI. And someone puts you in front of a product like ours where, yes, the web-based part of it is really important, but there's an awful lot of stuff behind the scenes that's also important. If you just focus your time on that web-based UI piece, give an example I was talking through, it might be one of the critical pieces, it might be that highest risk area, but it might not. Maybe it was the app code we were changing. And if you're only familiar with testing the UI, you're going to miss the highest risk area, where you're only going to get a sort of maybe touch on some of those risk points via whatever you can do in the UI. And that may not be appropriate or efficient. Or you might just end up spending weeks testing all the permutations through the UI, because that's really expensive and really hard work, all across the browsers, and not find anything interesting. And as soon as you give it to the customers, they're going to do something with a certain bit of data that you didn't test with, straight through the app code, and that's what's going to blow. In other words, you're looking over here when the bugs are really going to be. Similar and kind of related is you're not finding the important stuff. You're not finding the stuff that really matters because you haven't figured out what really matters. You haven't figured out what the areas are that are likely to break and which are the highest priority areas. In other words, the ones that are going to have the biggest impact if they do break, as well as the highest probability of breaking. So you might find lots of bugs around. You know, on IE11, this kind of bit of the screen looks a bit weird, and we want to fix that because it looks a bit weird. Meanwhile, there's a critical path in your software that's just completely failing, and you haven't noticed it because you're not looking at that. We're helping the team to work efficiently. So, as I said at the beginning, efficiency is a big part of this. If you're not helping the team in the sense of like, trying to get the design right the first time by spending a bit of time to analyze it, to spend a bit of time to try and avoid coding some of those things that we know are going to actually turn out to be bugs. That's an efficiency thing, right? If you have to fix something weeks, months, days after it's been released, it's super expensive compared to either avoiding it, which means you don't have to do anything, if you're just writing the code that's going to be more successful first time round. You know, it's just an order of magnitude difference in terms of getting a customer to have a problem and losing their sort of confidence in your product, having your support team have to deal with that customer and take time to work on that thing, giving it back to your dev team and having them work on it, try to reproduce it, and then you have to test it again. It's just super expensive. And you can't talk to that that release decision in any sensible way. You can just say, well, I had this test plan and I ran all these tests, or maybe you didn't because you ran out of time. And if you didn't prioritize those tests, maybe you didn't run the important ones because you ran the easy ones first, and then you left the hard ones to the end.
What would be your definition of test done?
My definition of test done? If you use this approach, it's basically that I've covered the highest risk areas. I mean, again, it's a time-based thing, right? So I should have started that with the it depends answer because it always does. But it's if you've got a fixed time and a fixed resource, like you were the only QA and you've got 1 week to do it kind of situation, then if you start with the highest risk and work down the kind of priority to the lowest risk, you're just going to get through whatever you can manage to get through. And sometimes you won't get through very far because the first thing you try, let's face it, the first thing you try is the highest risk. It was definitely the highest likelihood of something going wrong. You find a bug, maybe you've got to stop. If that bug blocks you from doing anything else, like the product is crashing or it's completely unusable, then you kind of stop at that point and you have to sort of go back and get some help to fix it and come back to this. Which typically, if you've got that fixed time scale, means that you've now got even less time to do the rest of it. So that definition of done really becomes that, how much can I do within that constraint? And have I done, consciously, have I done the stuff I needed to do first? So if you got to the end of that week and didn't manage to finish your high priority risk areas, I would definitely say you're not done. I would definitely say at that point that you could tell before you get to that point you're not going to get there. So talk to your team and your manager and say, I need more time because I haven't even been able to cover the high risk areas. Or you could pre-agree, like you could have almost a contractual sort of thing with your team to say, can we define done as being like covered the high and the mediums? Maybe that's the way you want to decide it. And then you have that flexible time in the sense of you take as long as it takes to cover the high and the mediums before you say you're done. Then you release. That makes sense?
Your examples and a lot of the stuff about risk prevention seems to focus around the design stage. But have you ever, because my experience is a lot of the risks are introduced even at the requirements drafting phase when you're writing the stories in the ACs. So do you have any thoughts or input on that?
So I meant to cover that as well. So I do focus on design because realistically, when you're actually designing and trying to solve a problem in code, you introduce a lot of issues. There's a bunch of issues that happen at the requirement stage. So we use BDD, so we use the behavior-driven development approach. What that really means is you're getting, the person who's asking for that thing, so in our case, a PM, customer requirement, if you like, the person who's going to develop the fix for that, the solution for that, and QA in the same room. And you're talking about those requirements in a way that you want to fully understand what it was the customer wanted, why they wanted it, and I talked about the benefit and value statement of really understanding that model. And then being able to use that to say, okay, we're going to write some tests at that point, at that time, before anything's written, any code is written at all. Using the understanding of the ACs, using the understanding of that customer need and requirement. We're going to write some tests that we're all going to agree on to say, these are the crucial, critical, top-level tests that are kind of like probably system or end-to-end or UI-focused tests that prove that when we've delivered this thing, it does what you wanted it to do. So ultimately, the PM signing off. And that removes the vast majority of those requirements-based issues because you've now made sure that everyone's on the same page. They all have the shared understanding and they have a test first before they do it.
So just to follow up on that question, how would you interleave the two dimensions, like the design dimension and the user requirement dimension when you do your risk analysis?
They follow each other. So this is all iterative. Yeah, it's a good point. I should have kind of elaborated on this a little bit into the process, but you start with the kind of someone comes to you with hey, we have this need, we want this thing, and that starts that process going of now I'm going to have the conversation about the requirements. Once I understand the requirements really well, and have for us we have a kind of gate of you need to have those acceptance tests kind of written and everyone shared that understanding, then you can move on to the now ready for the development stage, which is when you start talking about design. But typically those things kind of blur a little bit in the sense of as we're talking about what it is we need to do for the customer and get those requirements kind of understood, we also tend to blend into how are we going to do that? What does that solution start to look like? It might be a super high level diagram like I've done, to sort of say, well, roughly we're going to have to change this bit of code, that bit of code, that bit of the system, that bit of the system. So you're starting to get a design conversation already. And then as you progress through that, if you've done the requirements bit, the kind of customer rep, the PM in our case, can leave the room, and you can carry on having a deeper design conversation. So you can say, okay, maybe we're talking about this, and I've got this idea that this part of the product, maybe it's the UI, is actually the highest risk area, then you can say, okay, so what are we really changing in there? We know we're changing something, but what does that look like? And you can explode that sort of diagram into, well, there's these components in a JavaScript, in that UI, and here's the bits that we're adding or changing. Maybe we're introducing a third-party library, whatever it is, you can start to talk about that design in detail, start to see the risks at that level, and have that conversation, that understanding.
So at the end of the day, when you have prioritized all your test cases, and you're dealing with the high-risk ones first, and then you're moving downward, that the risk rating, or how you index those test cases, have taken into account both the user requirements as well as design risks.
Yeah. So one of the things I want to pick up on what you said there was, I don't know if everyone heard you, but you talked about like coming out with the test cases and prioritizing those. That's the last thing you do. So what you're trying to do is you're trying to defer into that last responsible moment when you write those test cases. Because you want to make sure you've understood things first in order to really come out with the test case. So I kind of capture things like high-level test ideas, like I know I need to test something around this thing, and I iterate on that too, and sort of say, okay, I want to refine that into something that eventually becomes a test case once I figure out that what is the thing in that area that I want to focus on testing. Because often, there's not many of my folks here right now, but if you talk to them, it would be how does that really work? Because I'm trying to drive the developers to write tests at a lower level. So the idea is to sort of say, I want to fail fast. I want to have like a unit test that's going to figure out that tiny piece of the design. How do I make sure that's going to work and not fail in the way that I think it might by writing a unit test for that. So I'm kind of pushing that test case idea right to the developer, right to the lowest level of code, so that it's one of the first things that gets kind of written and automated, and the first thing that's going to run in my pipeline and give me that feedback. Does that make sense? But I'm only doing that, I'm only getting to that point when I actually come up with a test case once I've gone through that kind of risk analysis, once I've gone through that, like, oh, I can see what's going to happen, I can see that I identify some area of risk here, and I've identified that as a high area, so now I'm going to spend more time digging into that area, understanding deeper, until I get to the point of saying, now I really understand where the risks are going to be, and it's that bit of code right there that we're about to write. Now I'm going to write a test case for that. So use the risk to drive your test case. Don't start with a set of test cases and then just try to prioritize those against the risks you're identifying. Start with the risks and then come up with a test case that mitigates them.
Yeah, I guess the point I was trying to make though is that at that point in time where you determine that the risks are high in a particular area and you decide now to start writing test cases, those risks have been assessed from both dimensions, from the business importance of dimension to the design dimension.
You saw the big wall of text I had there of things that I'm considering. There's an awful lot I'm considering. I mean, you're right, there's kind of broad categorizations of kind of business and design, but there's actually a lot more in there too. A lot of consideration to be made.
Balancing between the analyze higher risks first and using the heuristics where you want to say, okay, I'm looking at structure and data and blah, blah, blah. But structure might not be your highest risk thing. It might be all the way at the end of your heuristic.
Right.
You also don't want to start skipping around because you might miss something.
True, and a good point. So I'm not using the heuristic to focus risk, I'm using the heuristic to get the understanding that it allows me to assess the risk. It may sound a bit meta, but like if you use the SFD for example, right? So I'm using structure to say, what is the structure of this thing? What does that mean? In whatever context I'm in, what is that structure? And you're using that to sort of get that understanding of what the structure is, and then you're thinking about the things that you learn from that structure that you then think could go wrong. So if your structure makes you understand that, okay, we're talking about a DB, it's an obvious one to talk about, so there's a database structure, and maybe we're changing that. And that's what the structure part of SFD has got you thinking about it. And now you can think about, are there any risks with that change to that structure? Does that make sense?
How do we deal with the risk of failure to identify?
How do we deal with the fact that we're imperfect people? Yeah. I mean, it's very true, right? So this isn't like the only thing that's going to solve the world problems. This is not silver bullet by any means. It's just an approach I take, and one of many. So the other thing you need to do is to say, well, I'm creating artifacts along the way that kind of act as my kind of somewhat documentation of how I come to some of those things, right? So you've identified a bunch of risks. Maybe you've got a whiteboard diagram with some colors and notes on it that you've kind of stored in your card or whatever it is you're using. And then you've got a series of tests that you come up with to say, I want these tests covered, and then you've got some results against those tests to say, I did these things and I didn't do those things because I didn't get to them. And then you ship it to the customer, and the customer then reports a bug. Then what you have to do is kind of go backwards along that chain and say, okay, so this customer bug occurred in this area. Now, how do I understand where that bug got introduced? Like you do that analysis on the bug and say, where did it get introduced? And was it in one of those areas that I identified as low risk, in which case I didn't cover it at all, perhaps? Then it's an obvious situation of maybe my miss was I thought it was low risk, but actually it turned out to be higher than that. Or it could have been in one of the high risk areas you did cover. For some reason, you didn't think of that particular situation, that particular set of data or environment or whatever it was. And then you have a different learning that says, how did I miss that? What didn't I think of? Or what didn't we think of that could have led me to understand that risk? Because you've got a bit of, hopefully lightweight, fairly cheap to produce kind of documentation as you went along, you should be able to go back and kind of pinpoint, oh, yeah, I think of that one. And then you learn from that and add it to your risk catalog or your heuristic or whatever it is. Get better. Don't be perfect, just get better.
So what you've been describing here sounds like it would work well in a business where your software development process gives QA access to the development side.
Yep.
On the more agile thing.
It works in waterfall too. I mean, I've done that. My answer to that, and I know where you're coming from, because I talked to a lot of people that are in this situation where they're not allowed to see some of that stuff, they're not involved in some of that stuff. The kind of organizational structure prevents that. The answer I've got for you for that is making so, like, try to actually put yourself in that position, find a way to get involved in that early process. Or if your organization just literally forbids it, then honestly, your organization is stopping you doing your best work. So, choose.
And what about dealing with the situation where the QA people are not necessarily developers, may not be well trained as developers are.
Yeah.
So they may not have the capability of really understanding the architecture and the issues and that type of thing.
And that's very true. You will also never get that understanding unless you start asking questions about it. So, like, I don't develop on a daily basis, but well, Teresa, what do you think? Like, do I know what I'm talking about with this stuff when I challenge people on this? Have you seen me do that?
Yeah, and I think that it's almost better if you don't know what's going on, because then you're asking questions and people are questioning their own assumptions.
Yep.
Someone will start answering and then the next person will go, no, actually.
So I often approach this as, I'm the dumbest person in the room. So I'm going to ask you questions about it because I clearly don't know. I have no background to understand this thing. So I'm saying to the developer, explain this to me. Why this? Why that? What happens when? What happens if? And by doing some of those things, you can often get into that, like I described it earlier, the shit moment. But even if you don't have kind of some of that background to be able to do that, you've got to realize that if you can get someone to draw a diagram and there's a box on there, it's got something going in and something coming out. It's a black box. We all know how to test black boxes. Even though we don't understand the internals, we can ask enough questions to say, what are those inputs and what changes them? What's the decision you're making and how are you making it? Or what's the thing you're doing inside that box? And what is that result based on? And at that point, we're actually using the skills that we're quite well used to using. We're using them at a lower level in the architecture. We don't need to necessarily have been the ones drawing that architecture to understand it. If you can get someone else to draw it for you, then they're going to sort of draw those boxes, and then you can ask the questions, okay, so what's going in, what's coming out, how do you decide? Then you can apply your traditional testing technique. So yeah, I challenge anyone to.
And then what about getting management to accept that QA is going to get involved in this level and it's going to take more time and resources possibly to do this thing?
That's tough. Like it is. It's easy for me because I'm the manager, but like it's tough in the sense of you're trying to basically sell a value proposition without being able to show it. So you're essentially saying, okay, give me some time at the beginning of the process, and as a result of that, I'm guaranteeing you, or you're going to trust me, that at the end of the process, it's going to have gone quicker because we won't have had so many bugs and had to rewrite things or anything else. So it's like, I often describe it this way, like selling insurance. Something might happen bad over here, so you've got to pay for insurance now, so that if that bad thing happens, you're protected. It's kind of like that idea. I'm saying, buy this up front, spend this time up front, and I've just given you a kind of a fairly hard example of I spent 7 sessions going through this thing. So it was painful, and it was really hard for people to sort of say, well, why are we doing this, etc., etc. It was only at the end of it they really got the idea that, you know what, we went through 3 different designs, and had lots of kind of back and forth, and everybody came out of that room with like really solid understanding of what was going on, why it was going on, and why some of the other designs weren't good, and why this design was a good design. So it's a huge learning curve in that kind of 7 hours, as well as the fact that we stopped ourselves designing something that might have worked at the first instance, but very soon after would have failed badly and we would have to rewrite it. So once you've gone through, if you can just get one of those and show that value and get someone like a senior dev to go, yeah, that was super valuable, I want that guy in my next meeting, then you kind of got to win.
Yeah, I think it's going to be a tough sell because you're trying to sell someone on doing something up front to avoid problems later on. Right? And if the problems don't happen later on, everything goes fine. You think, well, why did we need to do that? Because it all worked fine.
And that's a classic problem. That's exactly what we get a lot.
And it's that old saying, you know, there's never enough time to do it right, but there's plenty of time and money to do it twice.
Yeah, I actually use the quote myself because I rail against my team for that. Like, why don't we have time to do it right? We have time to do it twice because we do, right? We end up at the end of the cycle sort of going, oh, we found all these bugs, and now we're going to go back and fix it. But the developer's already gone off and doing something else, and now I'm going to interrupt them and get them to do this. It's like, look at the cost of that. Just look at the data around that. You know, how much time you spend doing things. Do you spend time on bugs? Do you spend time on feature development work? And try to use those as your or use the requirements analysis approach, right? Like you wouldn't go ahead and build something without checking the requirements. You know that kind of old carpenter's kind of saying of measure twice, cut once? Like, that's such a simple thing that everyone can conceptualize, so why not spend that bit of time doing more of that measurement, doing more of that analysis before you actually make that cut? Because software development's expensive, right? If you're doing anything meaningful, it takes time, it takes energy, it takes effort. You don't want to waste it. Testing's the same, right? I don't want to waste my time testing the wrong things or testing things that I know are probably going to work just fine and ignore the things that I know probably aren't. It's just crazy. Cool. Me? Yep. Yeah. Awesome. Cool. Thank you very much.
And Stuart has offered to give us the slide deck, so I'll be uploading that and posting it to yeah.
It won't be today.
Eventually, yeah. So I'll be posting it on the VanQ group. Yeah. And then you can put on your blog as well.
Yeah.
Okay, cool. So we can post this everywhere.
Yeah.
Cool. Awesome. Thanks a lot.
Thank you.
Great. Thanks, guys.